All right, everyone, welcome to another episode of the TWiML AI podcast. I'm your host, Sam Charrington, and today I'm joined by Ziad Asghar. Ziad is Vice President of Product Management at Qualcomm. Before we get going, be sure to take a moment to hit that subscribe button wherever you're listening to today's show. Ziad, welcome back to the podcast. It's been about a year, just under a year since the last time we spoke.
Yeah, thank you for having me. It was awesome and great to be back.
Absolutely. For those who don't remember you or didn't catch that last show, why don't we start out by having you share a little bit about your background and your role at Qualcomm?
Sure. Yeah, my name is Ziad Asghar. I lead all the Snapdragon technologies, including all the things that make Snapdragon awesome in terms of the great camera and image quality, AI, graphics, all the capabilities that come together to give us the best experiences across all of our different product lines, smartphones, auto, and other areas. But definitely, AI keeps us a lot more busy. It's a lot more of an exciting and up and coming area. So, spend a lot more time on that. And along with that, I spend quite a lot of time also managing the overall Snapdragon roadmap.
Got it. And you've jumped right in and brought up Snapdragon. Some folks might not be aware of what Snapdragon is and the role that it plays in the device that may be in their hand. Uh, Give us a little bit of background on Snapdragon.
So, Snapdragon is basically our product line that essentially brings in all the amazing technologies on gaming, on image quality, on rendering capability, on display subsystems, on AI, and then those what we call it as the one technology roadmap, where we develop these technologies and then take it to all of our different product lines, such as AR, VR, and automotive, and IoT, and mobile, and many of the devices that people carry in their hands and the amazing camera experience or the amazing graphics experience and all, it's coming from the goodness that we bake in with our technologies in the Snapdragon product.
And so, in this conversation, we'll talk a little bit about the applications that you are seeing across these different use cases that you've mentioned: auto, robotics, IoT, AR, VR, and some of the ways that you're addressing those. Let's jump in by starting to talk about things on the mobile side. What are you seeing there?
Yeah, I mean, mobile continues to be an amazing place for where AI and artificial intelligence brings in just a completely different level of experience. Really, a place where all the different use cases that we have, they get much much better. And last time I talked about how AI, I almost look at it as a horizontal technology which kind of touches all the other technologies, and we're seeing a lot more of that. I mean, we just launched our Snapdragon X70 modem subsystem, and this is the first 5G modem that's AI enabled. And what that means is that now we are actually applying AI techniques to make comms better, as in communication systems, much, much better. And for example, we're applying it to be able to get a signal or receive a signal with better quality in the most challenging of channel conditions, right? It's just one example of how we are going about doing it in the case of modem. But along with that, we talked about it at our launch last year, but the new applications that are coming up are just amazing, right? So now we're seeing a lot more of health related applications, for example, coming on mobile. So we had this engagement with one of our partners, Sonde Health. And essentially, what you can do is that as you're using your device, the device is listening, and based on your breathing patterns, it can actually start to diagnose if there are certain conditions. And especially in the era of COVID, this is something that is absolutely critical and useful. So we see a lot more of that happening. I think another aspect that doesn't come through as clearly, Sam, is the number of devices that we are in on the body. For example, a smartwatch, we have hearables, we have a smartphone in your hand. It is almost like a network on your body, and with that we're actually able to get quite a lot of health information from heartbeat, from temperature, and other areas. And we can, this is really an untapped area in my mind where we can actually do a lot more with mobile itself.
Just to you've already shared quite a bit, and I wanted to jump into that first point that you mentioned, the AI enabled modem. This one's particularly interesting because, as you know, I spoke to your colleague on the research side, Joseph Soriaga, about some of the technology, the channel matching technology and how machine learning algorithms are used to enable that. It's great to kind of see the circle close or the loop close and see that get into a production device now.
Absolutely, yeah. So, I mean, we have a very good story where we have the core, our research team basically leading in, and then we have a very good path to commercializing those technologies. And this is really an awesome example of how we started working on the research aspect of it on all the different vectors within the modem where AI could enhance performance, and now very quickly we're actually able to bring that to a product. And that's where I think the Qualcomm technology gets an edge because we have a very quick feedback, like you pointed out, from research getting into commercialization.
And that modem is something that that's used across the various use cases that you mentioned, both in mobile devices as well as in vehicles and more enterprise IoT environments.
Yeah, actually, that's a very good question, Sam. So, just like I talked about the one technology roadmap, we looked at modem also as that key enabling technology, of course, from our perspective, that's connecting all these devices together. And once we develop this technology, this core IP then is able to go into mobile, into a handset. It's able to go into an automotive for telematics like application. It's able to go into an AR or VR device when you have to be connected to be able to get all those experiences in, or an IoT device. So, and then from the smartphone roadmap perspective itself, it will start and go across our whole portfolio from Snapdragon 800 all the way down to the lowest end handsets. So we are very quickly able to take a research idea into first commercialization and then really disseminate it across all of our different product lines.
Can we dig into auto a bit and what you're seeing there? I think as an industry, we continue to be excited about the promise of connected vehicles and autonomous vehicles, or at least increasing autonomy within vehicles. How are some of the AI technologies that you're working with impacting that?
So auto is a very very interesting one. As you guys know, there is a lot of research. There is a lot of new ideas coming in. So from an automotive perspective, the great thing for me looking at the horizontal AI technology has been that initially when we started working on it, these were ideas that we were taking from our mobile or handset side and moving that to the automotive side. But increasingly, what is happening is there are things like, for example, depth-wise processing of neural networks that really started with auto, and with time, we're seeing, hey, there are huge benefits to this. So we're actually taking it from the automotive side and then bringing it onto the mobile side, for example. Similarly, as you know, there are certain sensors that you have within auto where basically, the sensor data is fairly sparse. So some of the sparsity benefits that we're getting on the automotive side, again, those are coming into other areas as well as we are basically evolving with time. And the other aspect where I think auto will probably lead also is going to be really this idea of multimodal sort of AI. Because what's happening is you have so many different sensors on the automotive or on the car now. Basically, you have to combine the lidar, the sonar, the multiple cameras that you have. Then, of course, there is a lot of data that's coming in. For example, the images that the car sees, the text that it's able to recognize, the NLP or certain words that might be said in the cabin. And so, really, to be able to create that full picture, there is a lot more work that I think the industry is looking at and we are looking at internally as to how to be able to leverage what we call like cognitive AI or this multimodal AI notion of it. And then I think once we have that developed, again, this is something that touches all of our business lines, and the scale really helps us to be able to take those learnings and very quickly apply it to all the other areas. And maybe one last one I'll mention is there is a lot of need for tools, especially from automotive perspective, to be able to hone the best in class experience on the AI side. And those tools, really today, at least on our side, we're developing them for auto, and then we're bringing in onto the mobile side. So really, very very exciting. As you know, we also just completed our acquisition of Arriver, which also gives us a lot more capability on the automotive side to be able to take the full computer vision stack and integrate that with our chips and hardware to be able to get the best in class experience. And maybe the last one that also we're looking at is kind of like almost what we call shadow mode in auto, right? Automotive is interesting because you almost need to get to a point where you want all the data from the vehicle going to an AI and then looking at the decision that AI would have made and compare that to what the human actually did. And I think in that context, that's another very interesting, learning aspect that we are getting from automotive.
And so, how is that shadow mode being used?
So shadow mode is being used in a way, Sam, that basically, you essentially have two things happening in parallel, where all the sensors data is coming into the AI that's managing the car, and it would have made a certain decision, let's say decision A. And then you can see the decision that the human actually made. And that comparison of the decisions actually is a very key learning and training aspect that you can use to be able to make all your algorithms significantly better on the automotive.
How about on the robotics side? What are you seeing there?
Robotics side continues to be one which is, I think, especially in the industrial context, is very, very critical, right? So you can imagine basically a large industrial warehouse, for example, where you have multiple of these robots that are basically managing whether flow of materials or what have you. But basically, in doing that, you need to be able to navigate a path from one place to the other. There is object recognition, object avoidance. There is basically even being able to listen to commands in the future from humans. For example, if somebody's about to bump, you can say stop. But all of those things are coming together, I think, in the robotics area in a very, very strong fashion. And of course, we're still super pumped about our little helicopter that's on Mars. As you know, that's based on on one of our older Snapdragon products. But it's really cool to imagine, right, a product that we've worked on, and it sits on a different planet. It's just really amazing. But talks to the the breadth of technologies that we have in these products and how quickly we can adapt them to be able to do different things.
And are there examples that you can speak to of, that can help us get a sense for, from a practical perspective, how far along folks are in the industry in deploying these kinds of capabilities?
Oh, yes. I think what we are seeing is that there is a very strong need to be able to, continue to move the state of the art in particularly industrial application of robots. And the very good thing is all the ideas and technologies that you develop, for example, for auto or for mobile, are things that you can bring in over here as well. There is, in a way, the autonomy or the autonomous driving aspect is going to be there much earlier in an industrial setup than it's going to be perhaps on the road, right? It's a more constrained sort of an environment. So some of the work that we're doing over there is very much focused on that. And then, of course, tying in this multimodal idea that I talked about too. And then I think all the other techniques that we are looking at to be able to do it on a device that's, of course, chargeable in the case of an industrial robot, but still power and some of those aspects become very critical. And that's again a place where we have spent a lot of time and effort to be able to do more AI processing for a given amount of power, and that becomes a huge advantage for us. So, for example, I mean, we in this last year we also have been working a lot more on things like NAS, right? So neural architecture search. There is an engagement that we have worked on with Google on the mobile side, but this is extendable to all of our areas, where we're taking the ability to take a model and really be able to get the most out of it in the most efficient manner. As you know, with neural architecture search, you can essentially optimize the model either for latency or for accuracy. And what we are seeing is that there are quite a lot of benefits that we're getting in terms of accuracy. And even getting a few percentage points more in accuracy is huge. And with some of the work that we are doing, we are seeing the benefit come across. It could be a difference between two products bumping into each other, say on that industrial floor versus not, right? So definitely a lot of new aspects coming in to make robotics work, and then in the future that extends into other areas.
This is another area where I had a recent conversation with one of your research colleagues, Murali Akula, where we talked about the full stack approach to system development. And one of the examples that we went into in quite a bit of detail is some of the neural architecture search uh, approaches that you've used, and in particular, how you integrated that with capturing metrics on device to drive the architecture search process with on-device power consumption and other metrics.
Absolutely. So yeah, again, very good example of, very quick move from, I think, research to commercial. And that's really key, especially in AI where things are moving extremely fast. We've really been working on making sure we can actually reduce that gap. And many a times, it takes quite a lot of time, but I think our teams have done an amazing job of really being able to do it much faster.
And what about XR? That is becoming an increasingly popular topic with all of the talk about the metaverse and the like. Um, how do how do you see AI playing into that world and into the technologies that you're building for it?
Definitely AI is pivotal. I think it's pivotal to make AI really work, to make AR work and VR work. What we are seeing, Sam, is that at least in terms of the models that we need, for VR, the models that, as we engage with our customers, the models are quite different than the models that we might be used to. And that's what I was talking about earlier, right? That cross pollination that we have going on between areas really gives us a very significant advantage in terms of being able to make these technologies work better across the board. But specifically talking about AR and VR, I think there are so many applications. For example, let's take a case of us wearing, for example, AR glasses. Now, of course, you need to be able to identify all the objects. You need to be able to do, very good pristine 3D reconstruction. You want to be able to essentially do very exact hand tracking, for example, to be able to point to a certain thing in your field of view rather than, typing, because you, of course, now interact with the device by your voice or by touch. So hand tracking becomes right. So gesture becomes very critical, and it also becomes very critical to do it very accurately, right? It's a very limited area where you might be saying, oh, what is that sort of a thing? And essentially that needs to happen, and that's all AI. You have to do things like plane detection, because you need to identify, well, this is a table, and now I got to put this virtual object onto it. So all of that is essentially AI. It needs extremely good depth information, which we have been applying to. For example, a very good example of that is right on smartphone side, we started applying depth to portrait mode, because the bokeh effect that people are very that they like very much is essentially realizing the depth information from there, and putting some things in the foreground and some things in the background. And that's exactly the same idea that's now coming into AR and VR to be able to leverage that. And then you got to do things like eye tracking, for example. And along with that, we have other techniques like foveated rendering to be able to make sure that you're making sure that you're giving all the resolution to where the person is looking at, rather than trying to render at the highest resolution across the whole field of view, which can be very limiting, especially in devices that are small form factor. Power becomes absolutely key, especially as you talk about AR. And then lastly, of course, NLP comes into play. You got to do natural language processing on the device, and that's another aspect where we have done and shown some of the work that we did in at the end of last year, for example, with our engagement with Hugging Face, where we basically showed that you can essentially do what do you call it, emotional readout of a particular message from the text or the data that's coming in. Or what we showed, that let's say you have a whole list of notifications that are coming on your device. In the AR context, you're not going to look through those. But now with AI, we can actually figure out which one of those notifications are key, and basically bring that up to the attention of the consumer. So there's a lot of applications that we're looking at right now. We also launched Snapdragon Spaces, which is a very good platform for many of the developers to be able to start to develop a lot of these techniques. We have all the pieces available along with hardware to be able to make this a reality. So yeah, lots of investment going in there, but amazing amount of excitement. Uh, I honestly don't know what shape Metaverse takes in the end, but I think all the technologies that go into it, from computer vision, from NLP, and really even in computer vision, we have to look at combining AI and CV to be able to get to the right experience rather than just one or the other. So we're looking at that. We have to have the best in class pristine rendering capability and be able to render at the lowest power possible. So all areas that kind of come together kind of under my purview. So very exciting area for us.
That last point you mentioned is referring to kind of a fusion of traditional computer vision and rendering uh, approaches with statistical machine learning AI based approaches.
Exactly. So I think the answer, in my opinion, in many cases, Sam, is going to be a combination of that traditional approach, which is just a traditional CV, combined and augmented with AI overlay on top. And I think the two coming together is going to give you a very good, probably the best and most optimal solution. We're seeing this in some of the hand tracking algorithms already, that actually it's a combination of those two things rather than just one or the other. And actually, the analog of this, I see it in multiple areas. For example, in some audio cases, for example, some speech scenarios, or as well, it's a combination of traditional signal processing plus AI applied to the same thing.
I'm thinking of another conversation I had with folks on the research side that was using machine learning and deep neural networks to estimate the parameters associated with traditional models. It may have been that same conversation with Joseph. Uh, in his use case, the parameters he was estimating were these channel parameters for wireless, but that same approach and all that same research can be applied to other types of traditional models like the computer vision ones that you're describing here.
Absolutely. That's actually a very good example that you bring up, right? Because that used to be hardwired in the past. So it was
Mhm.
not able to adapt to the channel conditions, for example. Well, now you have the ability to be able to adapt it. So the underlying algorithms might still be traditional, but the parameters that are feeding into those algorithms are now modifiable based on our AI algorithm that sits on top. And that's actually an excellent example of exactly what we'll see, I think, in multiple areas.
You mentioned some work with Hugging Face, and you described it as kind of an emotional readout of something. Elaborate a little bit more on what you are doing there.
Yeah, so we are working with them on very cool things, right? So I mean, some of these NLP models are gigantic, right? They're really, really big. Like for example, BERT and some models like that. So what we work with them is on a very reduced version of it, like and working with them is distill BERT, for example, right? How to be able to port that and be able to run that entirely on the device. Right now, you have the ability to basically make that happen because of the amazing amount of AI processing that we put into the device. Just from our last year flagship to this year, we can almost do 4 times more AI processing, by the way, coupled with almost 70% better power efficiency. That is absolutely critical to do some of this stuff. But what that allows us to do is, for example, let's take an example of productivity in the future. So you could have a long document that you've just received from somebody, but something like this can actually summarize that document for you, and you are actually able to get the gist of it very, very quickly. Or you have 10 calendar invites that have just popped up onto your computer, and it can prioritize based on importance as to which one is the right one that you should go to at this point in time. So there are many applications that we will see, but in terms of virtual assistant, that emotional readout that I talked about, right? You can or sentiment analysis, I guess is what people also call it, is where you could basically assess that whether, if you have a virtual assistant with you, it can sense what the person is feeling. Is this a positive? Just from a sentence, they can actually read out and tell you if it was a positive leaning sentence or a negative leaning sentence. But what you can see is, these are the pieces, Sam. But I think between the NLP, between the fact that you can do distillbird, between the fact that you can do amazing echo and noise cancellation, and great speech recognition, and ASR and TTS, you're bringing all the pieces together to do a fully functional virtual assistant on the device.
Another application area that I'm curious to hear your take on is camera. You mentioned it briefly earlier. We've been in the midst of this kind of camera arms race, if you will, that has, largely, if not completely, shifted from one focused on kind of traditional optics to software. Has that run its course, or is there a lot more runway to innovate on the software and the camera side? And what should we expect to see?
Definitely a lot more to go there, Sam. So I think we're just starting to, of course, get a lot of the benefits in terms of, like I talked earlier, the depth work that we have done, lots of use cases coming out from that, lots of use coming out in the category of image quality improvement. So people are doing much better noise reduction, for example, in low light scenarios to be able to get more capability out of it. But now you can envision that, we showed this last time where you're literally able to, use AI to do auto zooming, for example. So what you can do is that, let's say you are picturing or recording your child running around a field or something. It can zoom in and out in such a way that even though the child has run out further away, but it keeps the child's height essentially the same, but you're zooming in and out in the camera. That's just one application that we have shown. But there is another one that now we're applying to productivity. So like we're talking on this video conferencing right now, many times you'll see people sitting on one side or the other in the frame. Well, you can do auto framing, right? Automatically it can crop out things and be able to set it exactly in the right location. And then coupled with that, you can envision now that as we do more augmented reality, and you will have basically video capture and camera capture with those virtual objects, and you can envision that there is a lot more that we can do over there also. So definitely a lot more use cases. The first step you're also seeing is a lot of the work that's done on a single frame now extending to video. So all the use cases, but that tells you, right, the amount of extra AI work we have to do on the device, because it happened used to happen once a frame. Well, now I got to 60 frames per second and still be able to get the depth information out, still be able to get the auto zooming going, still be able to get all those other aspects in. So yeah, a lot more runway and a lot more to come in terms of much better experience, and to get to a point where the optics can literally be uh, overcome with the application of AI and traditional techniques, and actually go much beyond that. Right, with the traditional optics thing, you did not have a context information, for example. Well, now we have a AI that basically has a full contextual information, and at the same time you can do a lot more in terms of, for example, taking out even the limited optics that you have, for example, in a smartphone. All the artifacts of that can be taken out, and there is an analog of this on automotive as well. Like when we work on a lot of these camera technologies, we all talk about or try to optimize it for human vision. So what that means is, right, the picture needs to look great. I'm going to do segmentation. I'll make the skin look very nice, and I'll look the cloth look different, and we do different processing on that. But in the auto context, it's very different. It's all about machine vision. So it's not just about making the picture look nice. It's about really knowing what's better, what is in that frame essentially. So, in the case of an auto scenario, you can have a fully lit half of the frame, and half of the frame could be in the shade, but you still got to be able to see through that. So there's different sets of techniques that we have to apply over there to be able to get to the best experience or the safest experience for the car. So yeah, a lot more runway on just capture in general, and then extension of that into AR, VR, and auto is bringing in completely new use cases.
Yeah, yeah, that's a great example. Another great example of this theme of innovation transferring from one area to the next, doing things for consumer cameras and having that improve what you're doing on the auto side, and vice versa. We touched on
Mhm.
IoT and enterprise applications a bit. In the past, we've talked about this idea of connected intelligent edge
Mhm.
and what that means. What's been happening there?
Yeah, I think that that vision we have had of really, a network where basically you have AI that's really distributed across all the different nodes of the network. It's really coming to fruition, right? You basically have, smartphones and wearables and hearables and automotive and connected cameras, and all of those have a certain degree of AI in them. But what you can do now is there are two or three key things that we have always driven for is number one, privacy. From a privacy perspective, you really want to do more and more processing on the device. But when there is a need for a certain kind of data to be processed elsewhere, well, you have this amazing 5G link in the middle to be able to get that data across as fast as possible to the other end where it could be able to access more AI. So the first stage was really, from a server perspective, inference just used to happen in the cloud. So with what we have driven towards is inference is definitely happening on the device and in a really, really meaningful way, and more capability getting packed into it. I think the third stage that we're really pushing towards now is not just inference on the cloud, but sorry, not just inference on the edge, but also learning and training on the edge. And I think that's going to be the next chapter where really you'll see us pushing a lot more. So just like we could do inference in the cloud and the edge, now I want to do training, which has been relegated mostly to the cloud, but also do limited part of that onto the device. And I think just in terms of use cases, that really opens up an amazing situation, right? Because now I can personalize things for you, right? Exactly your behaviors or your accent, for example, right? If you have an NLP running, or the way you drive that car, or the way you might, have move your head or something in an AR or VR like scenario. So that personalization aspect can only come from on device training or on device learning. Of course, it's going to be very, very limited from the perspective of what can be done on the device. But nonetheless, that I think is the next level. So all the pieces really coming together, and I think you are able to show a lot more benefit to the consumer, and that's really what it comes down to in the end.
There are also privacy and security implications to these federated learning use cases. Are those things that you're looking at as well?
Yeah, absolutely right. I mean, federated learning is now kind of the different aspect of it. So essentially, you were able to take it and let's say you were able to personalize, but then you had some more data available where you basically tweaked the model and made it even better. Now, the problem is that this is only this one node in the network that can benefit from that improved model. But with federated learning, if you can abstract away some of those data specific things or specific to the consumer and be able to share that back with the cloud, optimize the model, and then that improved model then gets sent back to all the nodes or all the different consumers, there's a huge benefit that can come from that. So we are making sure that that privacy aspect is there, that's encrypted in a fashion, and there is enough additional redundancy added to it such that there is no privacy information that can be taken out from that data, such that federated learning can really get to its full potential.
Thinking about all this from the perspective of the developers that are trying to build applications using all of this technology, what are you doing on the tooling side to facilitate them putting this stuff to use?
Yeah, I think this becomes continues to be more important. I think we've talked about this in the past also. I mean, hardware is definitely a challenge, but I think software and tools is really the space where you can yield so much more benefit. I mean, we have seen this with some of our products recently, where literally by the compiler improvements and some of the optimizations done, we have taken the same hardware and brought in almost 30% more capability to exactly that hardware. And I think that just shows the amount of extra the benefit that can be harvested from optimizing this work. So we're spending a lot of time and effort on compiler improvements, on model preparation. We are spending a lot of time on tools which we have called in the past our AI model efficiency toolkit. This has basically availability for quantization data. It has availability for things like model zoo, and all of these things are coming together to be able to allow the model itself to get better. Number one. Then number two, you apply techniques like NAS to be able to optimize the model even further to run onto our specific hardware. And then third things you do along with that is basically, of course, you continue to make hardware more efficient. So putting these three things together, I think that's where you're able to yield the full benefit of your hardware and be able to do more AI processing on the device than ever before. So yes, and like I had mentioned also in the beginning, Sam, we're doing a lot more of this on the automotive side, and then we're taking all of those learnings and then bringing it into mobile first and then into AR, VR, and into other areas as well, because the need on the auto side is a lot more pronounced. For example, an automotive customer really needs to understand, right, where what is the top line, for example, projection of the performance that we can get, right? That's one example. But it also wants to understand exactly where a particular change happened in the neural model, or to be able to understand each and every step through the way. You almost need to have like a bit exact understanding of a model, which is not really a requirement in other areas. But in the case of auto, it's very much needed. And then if you bring in, for example, cloud and all, there are additional requirements coming in. Even we are seeing this in the automotive side too, is the new data types, right? So there's a lot that's being said about, for example, 8-bit FP, right? 8-bit floating point precision that's coming in. So it's basically mixing in all of those knobs to be able to get to the best experience. And we at least are learning each and every engagement that we have with customers. We learn something new, and really allows us to improve our products a lot.
When I think of your developer ecosystem, I think of primarily kind of OEMs and vendors, OEMs on the auto side as well as on the device side. Do you also work with enterprise developers?
Yeah, so especially in the context of our compute platforms, right? So as you know, Windows and Snapdragon is a big initiative that we have inside the company. So we definitely are working a lot more with our partners on that side too. And the needs over there are again very interesting. Like I said, it's a different angle to what we have used in the past. For example, one of the things that people are looking at on the compute side is AI that's built into a browser. So you don't really have to basically bring it in and make the whole AI framework work for each and a different application. You can just have it built into a browser and you're able to get all of the benefits as you go about doing that. And then secondly, some of the productivity things that we talked about. especially from language understanding perspective, are very, very important. I think video conferencing use cases are very critical. I think this problem we talk about every time, right? You look at the person that you're talking to on video conference and your eyes are not in the right place, and you're stuck in this strange situation. So this is something, AI can automatically fix for you. There is noise suppression that automatically we can do far better than ever was possible in the case of AI. And especially on productivity. I mean, there are multiple times in the day where I, wish that I had an AI assistant on my email client that can basically take care of things, where I say, well, we should meet and discuss this or something on those lines. You would think it would be something where it can automatically find a room, it can find basically the people needed on the list, and just be able to do it. So I think those things are very close, but that's where you'll see a lot more, I think, benefit. And then the ability, you might have an email client on your handset, and you also have an email client on the compute side, and there are things that can happen between the two of them also, without requiring the cloud to come into play. That's another major aspect where we can bring in a lot more benefit too.
Let's kind of shift. We've been talking a bit about the future thus far, but let's shift and talk a little bit about what you're seeing coming up in the various areas that we've discussed. What are you excited about?
Yeah, I think it's like a kid in a candy store, really, honestly, for many of the people on my team, because I think the opportunities that, for example, Metaverse brings, the opportunities that ADAS brings from an automotive perspective, all the things that we would like to have worked on, well, all of those are coming, and they're demanding a lot more in terms of customer needs. So, like some of the major things that are coming on the horizon from an AI perspective is, we touched on it quickly, but I think cognitive AI is really a major one. I think this ability to be able to not be stuck in a single modality, but to be able to bring in multimodal sort of data into AI is going to yield huge benefits. Really starts to get to a point where you can almost argue that uh, where do we get to a place where AI might have even a conscience? I think we're starting to get close to that when we do some of that stuff with cognitive AI. But I think the benefits on, especially I think automotive and AR VR, will be huge. And then there is also some new things that we're looking at, for example, on data centric AI rather than just model centric AI. I think there's quite a lot that we can do, especially when we're talking about, I think, on device learning aspects. I think that's probably another big area that we'll spend a lot more time on. And then
Can you
definitely,
elaborate on that particular point?
yeah.
What's the intersection between data centric AI and on device?
Yeah. See, so what we have been very focused on as an industry has been much more on optimizing the model. But you can imagine that you can actually do very optimized labeling or very good labeling. So, for example, in the case of on device learning, one of the things which could be looked at as a subset of this idea is that you can do certain degree of learning at the enrollment phase. So when, let's say, you're getting used to recognizing that keyword, you can actually have the user say that 2 or 3 times, and now you have pristine labeled data that can actually make your experience a lot better for on device. And we have that ability with being so close to the edge to be able to bring a lot of that into the device. So I think you'll see, honestly, a lot more of that. You'll see a lot more of new types of data types continue to come in. And I think that's why the flexibility is going to be key. And the fourth thing we didn't talk about as much is really the ability to be able to do AI processing at always on like thought process, or which means that we have the big engine that we have in our products, but we also have been recently focusing on like what we call a sensing hub, or a very small AI engine. And you can envision auto, video, location, modem data, camera data coming into that sensing hub, and now you can actually glean a lot more information. For example, we think of this a lot more in the mobile sense, but think about your car when it's parked, and now you want to be able to make sure that the cameras around it are working, but they're working in a way that they're just sipping on the power, especially in an electric vehicle context, right? And well, this is a perfect kind of application of that, what we call like always sensing like camera. uh, and then I think the last one probably is this uh, horizon of a super stack almost on the software side, right? So like what I'm trying to drive towards, at least internally, is the ability to be able to have a stack that once your consumers and or your partners are able to use it, say in mobile, they can very easily leverage that in auto, in AR, VR, and you'll see us come out with some announcement also hopefully fairly recently, which is going to be talking about how we bring all these pieces together. So I think those are some of the big ones. But honestly, for the AI community, there's a lot more work coming, and I think it's honestly excellent quality work, and I think very fortunate for many of us who are working in this area.
Well, Ziad, thanks so much for checking in. It's been wonderful catching up with you, and looking forward to next time.
Likewise, always fun to chat with you, Sam. So look forward to doing it again.